Today we're going to solve linear and quadratic systems. So we are going to have a line for a linear function, and we are going to have a parabola for our quadratic. You can see the illustration I already have to the right. That's going to be our system. The point or points where these graphs intersect represents the solutions to the system. Right below, I've got the question, what ordered pairs are the solutions of the system of equations shown in the graph? So to the right, you've got a lovely parabola, a quadratic, and a line that is linear. Those intersection points are going to be our solutions. It looks like we have -3, 6, and 0, 3. Those are our two solutions. I'm going to write it down here as well. -3, 6, and 0, 3 are the solutions to this system because at those places, both of these functions share those points, meaning that's where they are equal. They both share that point of intersection, so they are equal at those places. It's easy to find the solutions graphically, and so we are going to use the calculator mostly just to graph them and see where they intersect. But you can solve these systems algebraically using substitution. So I've got an example for us. Y equals x squared. That x squared right there tells me it's my quadratic. Minus 15x plus 60. And then we have y equals x minus 3. That's going to be your linear one, your line. So let's start off with graphically. To the right, I've got steps for your calculator. So when you turn on your calculator, you've got your option on the left to start with Scratchpad or on the right, documents. Always use documents and use a new document. A lot of strange things happen on Scratchpad. So try to make a habit of always using a new document. Scratchpad will round weird, just awkward things happen in Scratchpad. So trust me, just always use a new document. We are going to add graphs. We are going to graph this system. f1 of x is asking you for your first function, and f1 of x also represents y. So we already have there y equals, and we're ready to type in our first function with x squared. Use the letter, and then you can use this x squared button for an x squared minus 15x plus 60. I'm going to arrow down. Arrowing down here is going to graph it and open the F2 box for me to type in my next function. If I hit enter, it will graph it, but then you lose that function box if you need it back. Hit the tab button and it will bring back your f of 2. I suggest arrow down. Like I said, it'll graph it and open f of 2. So then you can type in x minus 3 for your linear function, and now I would hit enter. So that blue parabola way up there in the right corner, that was our first function, and this red line is our other. In your steps, it says with a star, if needed, go to menu 4, window zoom, and 4, zoom out, and move your cursor where you want to center that zoom. So we probably want to do that just so we can see this graph a little bit better. Menu, window zoom, number 4 is zoom out. And see how my cursor says center with a little question mark? If you leave it over the origin, it's just going to zoom in and out over the origin and not help us out. So make sure you drive your cursor over to where you want to really zoom in and out. So let me sketch that for us, and then we'll take a look at solving algebraically, and then we'll come back to the graph to confirm our ordered pairs. So we had a graph that looked something like this. Let's take a break from the graph. Let's solve it algebraically and see if we match with the graph that's provided on our calculator. So to solve algebraically, we can use substitution, meaning I'm going to substitute one of my functions in for the other. So this bottom equation says y is equal to x minus 3. I'm going to plug that in for the y in the other equation. So replacing y in the top with x minus 3 equals the rest of that top function, x squared minus 15x plus 60. You would want to put it set equal to 0. So let me subtract x from both sides, and I will add 3 to this right side as well. That'll give me 0 equals x squared minus 16x plus 63. To finish solving this algebraically, we have a quadratic that we would need to factor. We are going to review factoring next week. So you would want to find the factors of 63 that add up to a -16. While 3 and 21 is a good choice, those factors do add up to 63, there's no way I can manipulate that to add up to a -16. So instead, let's use -7 and -9. Those will multiply to make a positive 63, and I can add them up to make a negative 16. Those will be our factor choices. So I can factor this as 0 equals x minus 7 and x minus 9. And you would finish solving by taking each factor and setting it equal to 0. Like I said, we are going to review factoring next week. I just want to illustrate that this does give us the same solutions if you do want to solve your system by hand. So I got x equals 7 and x equals 9. So one of our solutions is 7 something and the other solution is 9 something. You could take it and then plug it in. You could take each of those x values and plug it back in to say y equals x minus 3. I'm going to plug in 7 first. 7 minus 3 makes 4. And then I could do the same with the 9. 9 minus 3, y equals 6. So there's our two ordered pairs. 7, 4, and 9, 6. Let's go back to the calculator and see how we can use the calculator's graph to identify those solutions for us, so maybe you don't have to use substitution. So once you've graphed your system on the calculator, when you're ready to find your intersection points, you have those steps here. We're going to go to Menu, Analyze Graph, and then Intersection. So Menu, Analyze Graph, Intersection. And now you see my cursor up here is a dashed line, and in the bottom corner it says lower bound. So what it's asking for right now is, where do you want me to look? So the calculator is so powerful, it can look anywhere on this graph and beyond. So we kind of just want to give it some boundary lines to tell it where to look. So you want to go to the left side of the intersection point that you're looking at. I've had a lot of students in the past that want to be right up on it. You don't have to be right up on it. Just anywhere to the left is fine. And you're going to hit OK. Then it's going to change to upper bound. So again, it's just saying, hey, just where are you looking? As you slide, notice it's filling in some gray area. And it's already starting to pop up my first intersection point of 7, 4. So I'm going to hit OK and let that get labeled as our first intersection point. To find that other intersection, I'm going to do the same thing. Menu, Analyze Graph, Intersection. I'm going to hover to the left of the next intersection point and go to the right and hit OK. 9, 6. Is that what we got when we used substitution? 7, 4, and 9, 6. Absolutely. Those were the points that we had labeled. 7, 4, and 9, 6. And so we will use graphing to make this quick and fast because we are thinking about our EOC. We are thinking about benchmark testing that are all timed. Now, if you want to use substitution, you're welcome to, but graphing it on the calculator is going to be faster. And the more often that you graph on your calculator, the faster that you'll get at this process. So let's try number 1 below. We have y equals x squared minus 2x minus 4 and y equals negative 4x minus 5. The top one being our quadratic, the bottom being the linear. Let's put it in the calculator. So when you're ready for a new page, there's a lot of different ways you can get a new document. You could go back to the home page and you could get a new document that way. Another way you can do is Control Doc. Notice in blue there it says plus a page. You can also do Control I, will be like inserting a new page. Either way, you're getting this new menu. We are graphing, so add graphs. And notice now you can see how I had a 1.1 tab at the top and now I have a 1.2. So this is my next document. F of 3, because we already graphed F of 1 and F of 2 on the other tab. This is F of 3. I'm going to type in x squared minus 2x minus 4. I'm going to arrow down. This is going to graph it and open up F of 4. So I can type in negative 4x minus 5 and hit enter. Now look at this one. This black parabola and pink line are so close. It's really hard to tell if there is 2 intersection points or there is 1. It's kind of hard to tell. So you might want to zoom in. I'm going to go to Window Zoom. Number 3 is zoom in. I'm going to put my cursor right in that area and kind of zoom in and see. I think it might be 1 right there in that area. So I'm going to go back. I can do window zoom, and number 5 is standard. This is one of my favorite zoom options. Standard just takes us back to like the original standard calculator screen zoom. So it's kind of like a good reset. I'm going to go to menu and analyze my graph for my intersections and see if it identifies more than 1, but I'm really only expecting 1. Lower bound, I'm going to click over to the left of those intersections. I'm going to slide to the right, and it's only identifying 1 intersection, -1, -1. So our graph looked something like this, -1, -1. This is just one solution where our parabola and line are intersecting. Let's try number 2. Again, lots of different ways you can add another tab or open a new document. This time I'm going to show Control I. We'll just enter another page and I'm going to add graphs. I'm ready to graph x squared plus 4x minus 15. Arrowing down, graphs it, and opens up my next box for a negative. Now, the negative sign is different from the subtraction sign. Make sure you're using negative x minus 9. And enter. This one's kind of off the page, so I'm going to zoom out so I can see a little bit better. I am expecting another intersection point below. Menu, zoom. Number 4 is out, and I'm going to bring my cursor down here. There it is. Let's do menu, analyze, intersection, hover to the left and hit OK, hover to the right, and it's starting to identify our -6, -3. I'm going to go through those steps again. Analyze, intersection, hover to the left of that right intersection point, then drag it over to the right, hit OK again, and now we have our 2 ordered pairs labeled -6, -3, and 1, -10. So totally not to scale. We had -6, 3, and 1, -10 were our 2 intersection points. Those are my 2 answers. On the last page, I just want to emphasize one of our standards. It's when 2 functions, such as f of x and g of x, are set equal to each other and the resulting equation is solved, the solutions to the equation f of x equals g of x is represented by the x coordinates of the points of intersection. This ties in really nicely with systems. Look at number 3 to help illustrate what I'm saying there. Number 3, consider the functions f of x and g of x. They're graphed there. Looks like a system, linear and quadratic. You've got a parabola, you've got a line. What are the solutions of the equation f of x equals g of x? So we see this a lot, and it's such an easy standard. We just need the x values that would make this equation equal to each other. We're still using those points of intersection. So on the left, it looks like we have a -2, 6, and on the right, our intersection point is at 1, -3. I only need those x values, -2 and 1, b. Easy. Let's look at number 4. It's kind of laid out a little bit differently. Number 4 says, in order to solve the equation 2 times the quantity of x minus 3 equals x cubed, don't freak out, minus 2x plus 1, a student graphs y equals 2 times the quantity of x minus 3 and y equals the x cubed minus 2x plus 1. It's legal. They're doing the same thing that we just saw in number 3, okay? So in order to solve an equation that was really hot and messy, equal to each other, he graphed the first piece and graphed the other piece. What is or are the approximate solutions to the equation where they're equal? So I'm going to grab my calculator and guess what I'm going to do? I'm going to graph it and see where these intersection points are. So I'm going to do Control I, insert a new page. We're going to graph these. I know it says cube, but we're going to be fine. The first one is 2 times the quantity. Your parentheses are over here, x minus 3. Arrowing down, opening up my next box, we have x cubed, so not the squared button, obviously. Use the caret so you can put in a 3, and then arrow to the right to get out of that exponent, minus 2x plus 1. Enter. Ooh, okay. So notice this like odd polynomial. The right side is going up, 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 and away from the linear. I don't think it's going to intersect up there. All right, so let's do window, zoom. I think we can go out. Let's zoom out, and that's a nice picture. So down here in the left, I'm going to do analyze my graph for my intersection down here. Hover to the left, okay. Hover to the right, okay. I only care about the x value, -2.589, da, 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 da. And on my answer choices, we do have that. C equals -2.59 only. There was only one intersection point, and the x value is what would make the equation true. Look back up here at the equation. We only had x's. So that's the only piece that I care about, the x value that would make that equation equal. So we can use this idea of systems to solve equations that are equal. no matter what their degree, you could graph them and look for their intersection, and the x value would be what makes the equation true and therefore is our solution. So that's solving linear quadratic systems. We graph these. Let me put that there on the top. In a star, we graph these. This is different from those 3 variable linear systems we did in the last lesson, where we just went to the solve linear functions on the calculator, because that's for linear only. This is a linear with a quadratic, so we have to graph this and then use the analyze intersection to find those intersection points. But it's as simple as that. It might seem complicated right now on the Inspires, but the more you use it and the more you do it, that keystroke pattern is going to become easier and easier. So practice that, guys. Great week using the calculator. I hope y'all have a wonderful day, and I'll see you in class. Bye.